Each time a ball bounces, it reaches 95% of the height reached on the previous bounce. Initially, it is dropped from a height of 4 meters. Question A. What height does the ball reach after its fourth bounce? So this situation looks like this. The initial height is 4 meters. And after the first bounce, it reaches a height which is 95% of 4. So it's 4 times 0.95. After the second bounce, it reaches a height which is 95% of this, so it's 4 times 0.95 to the power of 2. And it's clear that after the fourth bounce, it reaches a height which is 4 times 0.95 to the power of 4, which is 3.26 to 3 significant figures meters. Question B. How many times does the ball bounce after it no longer reaches a height of 1 meter? Let's find after what bounce it reaches a height which is less than 1 meter. So a general formula for the height after the nth bounce is what? 4 times 0.95 to the power of n, and it should be less than 1. Using a calculator, we can plot two graphs. 4 times 0.95 to the power of x and 1. Window x is from 0 to 50, y from -1 to 2, and we need a point of intersection. And it's 27 point something. Definitely n can be positive integer only. What does it mean? That when n is 27, it means that after the 27th bounce, it reaches a height which is greater than 1. And when n is 28, it reaches a height which is less than 1. Hence, it does 28 bounces before it no longer reaches a height of 1 meter. Also, it can be solved applying logs on both sides. How it works: we need this to the power n to be alone, so we divide both sides by 4. And you remember, if you divide or multiply each term by negative value, you should flip an inequality sign. 4 is positive, so it remains the same. 1 over 4, or 0.25. Then applying ln on both sides. In general, it may be log to any base, it doesn't matter. Applying ln, and using that log to the base a of b to the power of m is m log to the base a of b. It becomes n times ln of 0.95 is less than ln of 0.25. Then dividing both sides by ln of 0.95, but notice that ln of 0.95 is negative. Let's check ln of 0.95. So it becomes that n is greater than. And it becomes ln of 0.25 divided by ln of 0.95. And you can see that we get absolutely the same result. N is greater than 27 point something, and since n is a positive integer, the first solution is n is 28, and it means that after the 28th bounce, it reaches a height which is less than 1 meter, so it does 28 bounces before it no longer reaches a height of 1 meter. Also, you may use that it equals, and also take into account that this function is decreasing function, and you get that n is 27 point something, and you understand that for n is 27 the value of a function is greater than 1, and for n is 28 the value of a function is less than 1. So the answer is 28 bounces. The next, what is the total distance traveled by the ball? It's clear that it bounces infinitely, and if we consider the sum to infinity with u1 to be 4 times 0.95, so u1 is this height after the first bounce, so the sum to infinity it's the sum of these heights after the first bounce, after the second, the third, and so on up to infinity. But it moves to and from, so we should multiply by 2 and then add these 4 meters, this initial height, so plus 4. Or it can be calculated as also 2 times the sum to infinity with u1 is 4, this initial height, and if you multiply by 2 you get this 4 2 times after the first, the second, and so on, and you can see that this 4 is calculated twice, so you should subtract 4. And the formula for the sum to infinity it's u1 over 1 minus common ratio, which is 0.95, so it becomes 2 times 4 times 0.95 over 1 minus 0.95 plus 4, or 2 times 4 over 1 minus 0.95 minus 4. So 8 times 0.95 divided by 0.05 and plus 4, it's 156 meters, and let's check this, it's 8 over 0.05 and minus 4, and you can see that we get absolutely the same result. Hence, the total distance traveled is 156 meters. And that's all for this question.